The DeckMaster electric remote controlled monitor from Akron Brass allows better personnel utilization and greater stream coverage with automated elevation deployment that provides ease of operation over obstructions while eliminating the need for extra extensions or telescoping pipes. During this educational video, we will review the DeckMaster monitor and how to troubleshoot issues that may arise. We will begin by looking at the available controls and how they are set up, then move on to cover system error codes and home sensors. After this, we will look at some basic troubleshooting tips as well as addressing some specific issues. We will also briefly discuss the optional electric riser and its usage and setup. Finally, we will take a look at where to find additional literature and documentation for this and other Akron Brass products. There are several controls available for the DeckMaster which can be used either individually or combined to give multiple control options for a single monitor. The first option, which is the standard or default controller for the DeckMaster, is the flush mount control box. This is typically mounted on the pump panel and has switches to stow and deploy the monitor, as well as rotate and elevate the nozzle and control the flow pattern if used with an electric nozzle. The second control option is the tether controller, a handheld unit that plugs into a connector mounted on the apparatus. It allows the operator a certain degree of movement around the apparatus and will control the monitor and nozzle, but lacks a switch for stow and deploy. The other option is the wireless remote control. This allows the operator to move freely about the apparatus while operating the monitor. This unit has controls for the monitor and nozzle like the tether controller, but has an auxiliary button that can be used to assign either stow or deploy, but not both. These controllers are arranged in the order of increasing complexity they add to the system, and depending on which are used, may require slight modification to the troubleshooting process when looking into a problem. But we'll come back to that topic later. If you have a DeckMaster with the panel controller attached, you've probably noticed the indicator light on the front of it that turns off when the monitor is stowed, turns on to indicate that it is deployed, and blinks when the monitor is moving from stowed to deployed and back. Hopefully this is all it has done and your monitor is working properly. Its other function, though, is to blink out error codes as the system registers faults. I'm not going to list them specifically here, but they generally cover problems such as not registering a sensor or the monitor not being able to reach its intended stow or deploy position. They are listed individually with descriptions and suggested fixes in the DeckMaster installation, operation, and maintenance instructions available on the Akron Brass website. If you are using a system that only includes a tether controller and a separate switch for stow and deploy, but does not include an indicator light, you will need to remove the cover from the logic box and look at the LEDs on the circuit board to see any error codes that are being displayed. The DeckMaster monitor contains two sensors, also referred to as limit switches, that are used to provide a limited amount of position feedback to allow the monitor to reach the desired position when stowing and deploying. It is a limited amount because, unlike a potentiometer, which is an available option for the DeckMaster but will not be covered with this presentation, the sensors that are used here are simple magnetic switches that use the location of a corresponding magnet to find a single designated position for reference. The sensors are only used for stowing and deploying the monitor, so let's examine how those functions work. If the monitor is in a new or learned stow position, the nozzle will be brought up so that it hits the hard stop, which is detected by a current spike from the motor. The middle arm of the monitor will then elevate until it detects the deployed magnet, while simultaneously moving the nozzle forward for a set period of time from the hard stop to reach its deployed position. To stow, an almost identical process takes place, except the monitor will first swivel left and right to find the center magnet. The nozzle then goes over backwards before the middle arm begins to move. The following two pictures will show where the switch and magnet are located for both elevation and rotation. The arrow in this picture is pointing to the elevation sensor that is mounted to the inlet elbow. It picks up the signal from two magnets embedded in the middle arm, one for the stowed position and the second for the deployed position. Both of these magnets are set and are not adjustable in any way, but the spacing of the sensor can be adjusted closer to the magnet if it is having difficulty picking it up. The rotation sensor is also mounted to the inlet elbow and picks up the single magnet attached to a ring on the base flange. It is important to note, however, that unlike the magnets for the elevation sensor, the ring that holds the elevation magnet can be adjusted simply by loosening the cap screw, holding the ring in place, and rotating the ring and attached magnet to a new location. This ability to precisely adjust the position of the rotation magnet can be very useful if the apparatus the DeckMaster is attached to has a very deep or narrow trough or cradle to place the nozzle in, or if there is a small window of movement available to clear an obstacle, such as the side of a cab or a ladder, while stowing or deploying the monitor. We are now going to cover a few principles to use when troubleshooting a problem with your DeckMaster monitor. The basic idea when troubleshooting a problem is to systematically eliminate potential causes or components that could be at fault through testing and observation. So where to start? Ideally, troubleshooting should be carried out with the truck running, since low voltage to the system can cause problems of its own. We recommend a minimum voltage of at least 11.5 volts under load to ensure normal operation. There are a couple of things that can be checked without opening up the logic box, such as observing error codes and checking the sensors for continuity when they are positioned over a magnet. But most of the diagnostic work is performed at the logic box. If your system is one that is lacking an indicator LED due to using a tether instead of a flush mount control box, you will need to open up the logic box immediately to look for error codes anyway. Before tearing into the wiring though, take a look over the system and make sure that all the plugs and connections are fully seated and in the correct sockets. Also, that the wiring in the logic box is correct and making good connections in the terminal blocks. The most useful equipment to have available, aside from knowledge of the error codes and a wiring schematic for the logic box, is a good multimeter. You will need to be able to measure voltages, not with a test light since actual values are more useful, as well as to check continuity and possibly measure resistance. The other tool that is helpful to have is a short jumper wire that can be used to simulate switch presses in the logic box by bridging the appropriate switch input contacts. So what is a logic box and where do I find it? The logic box is a gray box approximately 6 by 9 inches in size and will be located within 8 feet of the monitor. There is a wiring diagram on the underside of the lid. The U2 logic box, which is not covered by this presentation and should not be opened, has an identification sticker on top of the lid and has 2 plugs on the side of the box. Now that you know what to look for, let's take a look at some specific example problems. In this first example, the monitor does not respond to the controls. Now, this is a rather broad statement, so let's begin to narrow down the potential causes. If none of the controls are responding, the first thing to check is that power is being supplied to the terminal block 2, or TB2, pin 2, and is grounded to pin 3. If there is power to the logic box, then move on to terminal block 1 and check pins 10 and 24, which are the common pins that supply power to any controller wired to them. If those have power and the controller is functioning properly, then the terminal pin assigned to a given function, for instance TB1 pin 8 for deploy, will get power from the controller when the corresponding switch is pressed. If not, the controller is faulty. If the switch input receives power, but the board does not output power to the corresponding motor, then the board itself is bad. If the controls periodically do not function, or the monitor deploys or moves without touching the controls, then there is likely a short in the controls somewhere. One good possibility, especially if the monitor moves by itself, is that a sufficient amount of water has leaked into either the control box or the logic box to cause the short, which has resulted in a certain function not working or the monitor taking off on its own. There is evidence of significant leakage and corrosion to the control switches on the inside of the control box shown here. The same thing can happen with the logic box. It is also possible that a switch has gone bad or worn out, and this can be confirmed by use of a multimeter on the appropriate switch input pins in the logic board and checking either for voltage or continuity. Failure of the monitor to stow or deploy is also a rather broad topic, potentially containing any one of a number of causes and solutions. Accordingly, troubleshooting of this fault should begin with any error codes or simple observation of the stow and deploy process in an attempt to narrow down which part of the overall sequence contains the problem. By understanding the stow and deploy sequence, you can observe which step is not completed and use that as your starting point in the troubleshooting process. For instance, the stow process begins with the monitor rotating left and right to find the rotation magnet. If it rotates all the way to the hard stop and aborts the stow process, then the sensor has not picked up the magnet, and the sensor and wiring harness will need to be checked for damage. The sensor closes the circuit when it is over the magnet, so the continuity function on your multimeter can be used on the pins of the sensor plug to check that the sensor is functioning properly. The wiring harness needs to be checked as well. Pin 28 on TB3 is responsible for supplying voltage to both sensors, and pin 26 on TB3 will register voltage when the rotation sensor is over the magnet completing the circuit. Please note though that since there is a resistor in the wiring harness, you should only get around 7.5 volts on pin 26 for a 12-volt system. After the monitor finds the rotation magnet, the nozzle then goes over backwards to its hard stop before the middle arm begins to move. To deploy, an almost identical process takes place. If the monitor is in a new or learned stow position, the nozzle will be brought up so that it hits the hard stop, which is detected by the current spike from the motor. The middle arm of the monitor will then elevate until it detects the deployed magnet, while simultaneously moving the nozzle down for a set period of time from the hard stop to reach the deployed position. Another possible cause of stow or deploy problems is that one of the motors is not getting power or has gone bad. Since the elevation motor can be tested during normal operation, we will focus on the stow and deploy motor. This motor can be tested with a high degree of confidence with or without the use of a multimeter. Simply swapping the plugs for the elevation and deploy motors will allow you to move the middle arm by using the raise and lower switch on the controls, indicating if the motor is the source of the problem or not. Next, measure TB3 pins 23 and 24 to make sure the logic board is providing good voltage to the motor. To eliminate the wiring harness, either measure the voltage at the motor plug or swap the wires at TB3 pins 11 and 12 with those at TB3 pins 23 and 24. This will again allow you to operate the middle arm with the raise and lower switch, but this time through the portion of the wiring harness for the middle arm. If either of those two tests fail to operate the arm, the wiring harness is likely at fault. There are several other pitfalls when it comes to operation of the DeckMaster, or most other Acrobrass monitors for that matter, that are not significant problems but can be frustrating when attempting to set up or troubleshoot the unit. One of those areas is the array of 8 dip switches on the corner of the board which are responsible for turning certain features on or off. The default arrangement is shown in the picture with switches 1 through 5 in the off or downward position and 6 through 8 in the up or on position. Dip switch 8 in particular can cause problems since its function is to enable or disable learn mode. If it is disabled, the monitor will still use its learned stow and deploy positions, but will not enter learn mode to program a new position, which is a good thing to prevent accidentally setting a new position, but can create frustration if someone legitimately wants to learn a new position and can't get into learn mode. I won't cover all the switch functions here, but they are detailed in the DeckMaster installation and operating instructions available on the Acrobrass website. One other function that I will mention, however, as it relates to the next section of this presentation, is dip switch number 4, which needs to be flipped on to enable support for the electric riser. Another thing that can be checked while the logic box is open is the white sticker on the board that lists the model of monitor the board is programmed for, as well as the version of software that is used. This is more likely to be a possible factor with a replacement board or for initial setup, as compared to a unit that has been in service for a while and has developed a problem. It's still worthwhile to know where it is and where to find it though. The Model 3406 electric riser is a powered telescoping unit that provides an additional 12 inches of extension to the overall height of the monitor. This can be used if needed to help clear tall obstacles, or to allow the monitor to be mounted in a recessed or protected location and extended for use. You will need to order the electric riser with the mini universal controller, which mounts to the side of the riser, and connects to the riser motor and the DeckMaster logic box. You will also need the appropriate connectors for power and communication with the logic box. The wiring diagram to connect the riser's mini universal controller to the logic box is located in the installation and operating instructions for the electric riser. To find product flyers, CAD files, specs, and more on the Model 3440 DeckMaster monitor, visit our website at akronbrass.com and search by product name or style number.